Alright, today we are in Unit 2, Section 3. We're talking about the power rules. Our objective is the student will be able to simplify exponential expressions using the power rules of exponents. The power rule states that if a and b are real numbers and m and n are integers, then a to the power of n raised to the power of n equals a to the m times n power. All that's saying is if you have an exponent raised to a power to another exponent, that means that you multiply them. So in example 1, I have x to the 5th raised to the power of 7. Since I'm raising 5 to the power of 7, that means that I'm going to multiply 5 and 7, which is going to get me x to the power of 35. In example 2, I have 2 squared raised to the power of 3. Again, I'm raising 2 to the 3rd, and that means I'm going to multiply those exponents. So I have 2 to the 2 times 3 power, which is going to be 2 to the power of 6, which is 64. In example 3, I have 5 to the negative 1 power raised to the power of 2. Same theme here. I'm going to multiply these two numbers together. And I have 5 to the negative 1 times 2. Negative 1 times 2 is negative 2. So this is 5 to the negative 2 power. Because this is negative, what I need to do is create my own fraction by writing a 1 and drawing a line underneath. I'm going to take this and put it underneath the fraction. I'm going to put it in the denominator. When I put it in the denominator, this becomes positive 2. And 5 squared is 25. So this is going to be 1 over 25. In example 4, I have y to the negative 3rd raised to the power of negative 4. So I need to multiply these numbers together. This is going to be y to the negative 3 times negative 4 power. And this is going to become y to the power of 12. And that is the power rule of exponents. Up next, we have the power of a product rule. The power of a product rule states that if a and b are real numbers and m and n are integers, then a times b raised to the power of m equals a to the m times b to the n. So basically, we're distributing the exponent. As long as what's in the parentheses is all multiplication. You cannot have addition, you cannot have subtraction. Okay, so what we're going to do is look at example 1. I have a times 3b raised to the power of 4. So what I'm going to do, because everything inside the parentheses is multiplication, I'm going to distribute this 4 to the a, to the 3, and to the b. So I have a to the 4th, 3 to the 4th, and b to the 4th. 3 to the 4th here is going to be 81. So I have 81, a to the 4th, b to the 4th. In example 2, I have 4a times 2x raised to the power of 3. I'm going to distribute the 3 to the 4, the a, the 2, and the x. This is going to be 4 cubed times a cubed times 2 cubed times x cubed. 4 cubed is going to be 64, a cubed, 2 cubed is 8, and x cubed is x cubed. We need to put 64 and 8 together. That's going to be a cubed x cubed. 64 times 8 is going to be 512. So we have 512 a cubed x cubed. In example 3, I have negative 7, x to the 4th, p to the 3rd. So I kind of have a combination of things going on here. I have the product rule, which is what the last two examples were, but I also have the power rule because I have exponents inside the parentheses already. So when I distribute this power of 3, that's going to go to the 7. So it's going to be negative 7 raised to the power of 3. And then I have x to the 4th raised to the power of 3. And then I have p squared raised to the power of 3. So I have the power of a product rule, but I also have the power rule going on. I have to take these exponents and multiply them. So I have negative 7 cubed, which is going to be negative 343. I have x to the 4 times 3 power, which is 12, and p to the 2 times 3 power, which is 6. In example 4, I have 9a to the negative 2, x to the 7th, all raised to the power of negative 3. Again, I'm going to distribute the negative 3 to the 9, so I have 9 raised to the negative 3rd power. I have a to the negative 2nd power raised to the power of negative 3. And I have x to the 7th power raised to the power of negative 3. Because I have 9 to the negative 3rd, this right here, because I have this negative exponent, what I have to do is create a fraction with a 1 up top, and I'm going to bring this down to the bottom. That's going to be 9 to the positive 3rd power. Up here I have a to the negative 2 times negative 3 power, and x to the 7th times negative 3 power. This is going to be 1 over 27 times a to the positive 6th times x to the negative 21st. So what we need to do is put a and x in the correct places. A has a positive exponent, so it's going to go up top with this 1. X has a negative exponent, so it needs to go into the denominator. This is going to become a to the power of 6 over 27 times x to the power of 21. Lastly, we have the power of a quotient rule. It says if a and b are real numbers and m and n are integers, then a over b raised to the power of n equals a to the n over b to the n. B cannot equal 0 because your denominator cannot equal 0. So we just want to make sure that that doesn't happen. All we're doing here is distributing the exponent to both the numerator and the denominator of the fraction. So if we look at example 1, I'm taking 3 and I'm giving it to the x and also to 4. So this is going to be x to the 3rd over 4 to the 3rd, which is going to be x to the 3rd over 64. In example 2, I have 2 to the negative 3rd over y times negative 2. I'm going to distribute the negative 2 to the numerator, the whole numerator, and to the denominator. So this is going to be two to the negative 3rd raised to the negative 2 power over y to the negative 2 power. Negative 3 times negative 2 is going to be positive 6. So I have 2 to the 6th over y to the negative 2. Because this is a negative exponent, it needs to get moved. And we can't move it into another denominator because we don't have more than one. So instead of moving it down this time, I have to move it up into the numerator. This is going to become 2 to the 6th times y squared. And 2 to the power of 6 is going to be 64. So this is going to be 64y squared. In example 3, I have 3p to the 4th over t to the 5th raised to the power of 2. I need to distribute the 2 to this 3, to this p to the 4th, and to this t to the 5th. This is going to become 3 squared times p to the 4th raised to the power of 2 over t to the 5th raised to the power of 2. I need to multiply these exponents. 3 squared is 9, p to the 8th over t to the 10th. Lastly, I have example 4, 7pr over 14p squared raised to the power of 4. Now, if we want to make this a little easier on ourselves, what we can do is realize that 7 over 14 can be reduced to 1 over 2. I have p to the 1st over p squared. That means I have p to the 1 minus 2 power, and I have an r. This is going to be 1/2 p to the negative 1st r. P to the negative 1st, it has a negative exponent, so it goes in the denominator. R goes into the numerator. Everything is still being raised to the power of 4. We still have to do that. So I'm going to put everything in the correct place, and then we're going to raise it all to the power of 4. So I have p over 2r raised to the power of 4. I'm going to distribute the 4 to the p, to the 2, and to the r. This is going to become p to the 4th over 2 to the 4th, r to the 4th. 2 to the 4th power is going to be 16. So this is p to the 4th over 16 r to the 4th. All right, that is the power rule, the power of a product rule, and the power of a quotient rule.